Okay, hello everyone. My name's Michael Downey. I'm very pleased to welcome you to another AWRI webinar. It's great to see so many people that have logged in. In today's session, we'll look into whether certain labour-intensive viticultural treatments can impact on a producer's ability to make great sparkling wine. Joining me today to discuss the results from these trials is Dr. Fiona Kerslake, a grape, wine and cider researcher at the Tasmanian Institute of Agriculture at the University of Tasmania. Fiona's research focus is currently on influences on sparkling wine composition and provenance markers of Pinot Noir wines. Before we head over to Fiona though, for those of you in the audience, I do invite you to join in today's conversation. To provide a comment or ask a question, please open the Q&A section of the webinar, type in your question and click to send. If you'd like to get involved through Twitter, please use the Twitter handle @_AWRI. And just a quick reminder, the webinar is being recorded and will be available to view later this afternoon from the AWRI's YouTube channel. All registrants will receive a link to view this recording after the session. Now, I'd also like to thank Wine Australia for providing funding and support for AWRI webinars. For those of you that have just joined us, welcome. Today's topic is your hard work in the vineyard making your sparkling wine pop. And I'll hand over now to our speaker, Dr. Fiona Kerslake, to start the conversation.
Thanks, Michael, for that introduction. It's a real pleasure to be able to present this research to you today. It's been a project which has been quite a long time in the making, and it's got quite a large team of people who are working on it. So it's very exciting to be able to get it out to a broader audience through this kind of technology. So I'll give you a brief overview of the history of how we've been operating these projects down here in Tasmania. Initially, we started off with some viticultural trials in the 2010 to 2012 seasons. We were fortunate to have a significant portion of funding come to our research group through an AusIndustry AusIndustry grant from the federal government, which was also backed by a Tasmanian consortium. And so this funded both viticulture and enology projects, both in sparkling wine and in Pinot Noir. So for the sparkling wine component, the viticultural practices that we were taking a look at included crop load by way of pruning, so how many buds you left on the vine during winter, also taking a look at leaf removal and the effect of cane or spur pruning. So in these trials, we wanted to take a look at the effect on things like yield and fruit quality, composition. And during this period, we were also able to take a look at the base wines. But as most of you would know, of course, it's not all about the base wines. We've got to turn them into sparkling wines. And there's a lot that happens during that base wine to sparkling wine transition. This portion of the project, this is part of the team that was involved with that. So Dr. Richard Smart was also one of the primary instigators of this large research program, which also meant that we were fortunate enough to have Dr. Bob Danbergs down as an AWRI node in Tasmania during this time. It was quite a large group of people that were involved, so a lot of the Tasmanian wine industry, but also we had manufacturers like Flex Tank and Croplands involved, and also other agencies like Wine Tasmania and AWRI. So during this time, Bob and I rather ambitiously decided that we would tirage some of the wines in the hope that if we tiraged them and cellared them carefully, that we would be able to gain funding to take a look at these wines further down the track. So we were fortunate enough in 2016 to be successful in getting that funding. So we have a large sparkling wine project that's running here at TIA at the moment, and which is funded by Wine Australia and our industry partners. And the first part of that project is taking a look at the 2010 and the 2011 wines from those viticultural projects. So these wines have now had 5.5 years on lees, so which is a good maturation period. And so then we were able to open them up, taste them, analyse them, and get a better look at the effect of the vineyard practices, which we did in the vineyard in 2010 and 2011. We also have a project which is around maturation times and whether we can perhaps reduce the maturation time of sparkling wines whilst maintaining or increasing the quality of those wines. And we have a PhD candidate, Gail Ganoitsky, who's also working on that project. We have a project which we've been doing for the last 2 vintages, which is looking at whether we can sense in line the phenolic quality of juice as it comes out of the press. And we're getting some quite good and promising results coming out of that. And our recently arrived postdoc, Rocco Longo, down to Tasmania, has taken carriage of that portion of that project. We also have another project which many wineries around Australia have been participating in, which is where we are collecting juice samples from around Australia to see if we can find phenolic regionality or provenance of juice which is destined for sparkling wines. And we also have a master's candidate from Plumpton College, Hugh McCulloch, who's going to come over and spend some time with us taking a look at that data. So again, this is another big team that are working together on this one, particularly with the AWRI, who are helping provide a lot of the more in-depth analysis of these aged sparkling wines, so that then we can match that back to some of the compositional data that we had already obtained here at TIA, and also with our expert winemaking panel. And we've got a lot of industry involved in this at this point, but mainly through the Hillsmith family vineyards, Joseph Cromie and Apogee Tasmania. But today, just the project that we're going to talk about are the viticultural trials. So we had quite a few trials within this component of the project. So I'm just going to talk today about crop load in Pinot Noir through pruning and leaf removal in Chardonnay. And again, the time point that we're looking at these wines is 5.5 years on lees. So the 2010 wines, we took a look at those in 2016, and the 2011 wines, we took a look at those last year. So here at TIA, we completed the fruit and base wine analysis back in 2010 and 2011. Then, as I mentioned, Bob and I ambitiously tiraged most of these wines in 2011 and 2012, about 12 months later. We've had them here in our cellar at TIA, and then we've done the hand disgorging of the wines, and then we have run them through BEV scan. So we are just trying to take a look and see whether we can complete some of this analysis and discriminate some of the treatments between the bottles and have a look at what we might be able to pick up when wines are still in bottle. So we've been utilising that piece of equipment down here as well, which has been great. We've been working with our UV-vis, what we call spectral phenolic fingerprint. So this is where we take a scan of a number of wavelengths between 200 and 600 nanometers, so every 2 nanometers, and then we can compare the fingerprints of the wines and take a look and see whether we can see what some of the differences are between the wines, but also what might be driving those differences according to which wavelengths are contributing to treatment differences. So I'll go into detail on that a little bit later. We've been doing some extra analysis on the wines out at Joseph Cromie using their ENOPHOS, for which we've been very grateful for that access. And we've also been using a tasting panel at our Effervescence Technical Day, which we've had down here in Tasmania for the last couple of years. And so using expert winemakers to taste these wines. Part of the collaboration that we've been doing with the AWRI is looking at these wines more in depth. So been taking a look at polysaccharides, proteins, the volatiles, neuroisoprenoids and thiols. And also through Metabolomics Australia, we've been taking a look at fermentation-derived products and untargeted analysis to see if there are some other compounds which we haven't yet been able to quantify through the targeted analysis to see if any of those are throwing out some differences between the treatments. So I'm not going to be able to cover everything that we've collected for every trial today, but I will cover more off in the at the AWRI Sparkling Symposium that's being held in Melbourne next month. And also we'll find other ways to get more of this information out there as well at the end of the project. And we also have been working with the University of Melbourne to gather some extra data associated with foaming around some of the wines. So that's actually in the maturation project, but we're hoping that we can use some of that information that we've gathered and looking at protein levels and what have you, and be able to also associate that to viticultural practices. So it's a bit watch that space with that work that's very much ongoing. So just taking a look at the trial sites that we used in Tasmania, we have, although Tasmania is only one GI, we have quite distinct sub-regions, and they very much have their own terroir attributes. So there's not only soil differences that we've got down here in Tassie, but there's also quite distinct climate differences. So I just thought I'd give you a brief overview of the weather conditions for the 2 seasons that I've been talking about. So the 2010 season can be characterised as a warm and dry season, and the 2011 season was relatively cool and wet. So we had about 200 more growing degree days in 2010 in the north of the state, and about a degree difference in GST. So we had much lower rain during the sort of the growth period for the sparkling wine crop. And the interesting thing that I think about this, and which is quite relevant to our cool climate, is if we take a look at the mean January temperatures, there's not a huge difference between the 2010 and the 2011 seasons, but we all felt it. There was quite a difference. So I often look to using the mean February temperature, because this is the month of Oraison, and so you can see quite a big difference there. So if you look at, we've got 19.6 for 2010 in the north compared to 16.5 in 2011. And then at the southern location, we had 18 degrees as the mean February temperature, where it was, again, only 16.5 in 2011. So that's quite important when it comes to our ripening period. And this is a plot that I like to use, where if we put the 8-year mean as this thick black line through the middle, then the difference from the mean, the variation from the mean, is indicated by an upwards or a downward slope. So we can see that the big difference between the 2 seasons starts to kick in around February, as the MFT was showing. So this upward trend here shows that there's a warmer than average period than the 8-year mean, and then the downward trend shows that it's cooler than average. So I find that this is quite a nice visual representation to take a look at that. So if we take a look at the crop load Pinot Noir trial, the first vintage of 2010, this was actually the 4th season that these treatments had been applied to the same vines. We'd been running this trial at the northern site for quite a few years. So when we then started using it for these sparkling trials, it was quite good, because it wasn't the first year that the treatments were applied. So on the left-hand side there, we have the low crop load treatment, and this one is 10 nodes per vine. And then on the right-hand side, we have the high crop load treatment, which is 60 nodes per vine. As you can see there, it led to some interesting wrapping down of canes on that high crop load treatment. So here are some of the parameters that we measured back in 2010. All the fruit from both treatments was harvested on the same day. We can see that we were getting the yield differences that we were after between the low and the high crop loads within each season. But what we also got was, with the more than doubling of the crop load, we got a reduction in the sugar accumulation. So that was delayed by the higher crop load. In 2011, we also saw a lower pH as a result of that higher crop load, but then the TA results varied a bit more than that, and the pH in 2010 wasn't much different between the 2 treatments. So this is just what I was talking about before, the UV-vis phenolic fingerprint. So this is looking at the base wines. And what we can see here is, well, I should say with the base wines, we developed a standard protocol for our winemaking. And with all of these trials all the way through, effectively we took the fruit and we applied all the same winemaking all the way through, including, tirage and disgorging, so that we could see the vineyard effects come all the way through into the wines. We tried to get rid of botrytized fruit, but we weren't quite 100% successful with that one here. So we've got these two outliers here in our high crop load, and I would say that that was botrytis that was in the middle of the bunches that we couldn't quite visually see when we're doing our fruit sorting. So the clearest thing that we can see here when we look at the base wines is that the biggest driver of the differences in these base wines was the season. So the 2010 vintage are all over on the left-hand side there, and the 2011s are all over on the right-hand side. And when we take a look at which wavelengths actually start driving this separation, we can see that the wavelengths that generally feature are indicative of low molecular weight phenolics like hydroxycinnamate. So what we were looking for in this was to see whether we could subjectively assess with a rapid method whether we could discriminate wines that might be different in flavour and mouthfeel, texture and mouthfeel, sorry. So we could see that there was a big difference between the seasons, and we were hoping it would do that because of the warm and dry 2010 and the cool and wet 2011. And then we also saw that there were treatment differences within the seasons. So in the 20 and 10 season, the treatments actually separated out quite nicely, and they were sort of more to do with wavelengths around sort of 260 and 330, so more the hydroxycinnamates, whereas the 2011s, they separated out, but they were horizontally. And so that was actually more indicative of our total phenolics measurement around 280. So it was interesting to see the different responses to those in each year. So we did, just taking a look at the wine analysis that we did for these wines once they had been aged for 5.5 years. So these are now the aged sparkling wines. We didn't actually see, there isn't a significant treatment effect as a result of the crop load levels. So we saw that there's quite a significant vintage effect between the 2010s and the 2011s in the TA, also in the pH, and also in the malic levels. So, but we also didn't see that there was a different response to any of these 6 parameters according to season, because I did wonder whether we might see that in one season you would see, like say in the warm and dry season, you would expect to see, you know, a higher TA as a result of the higher crop load, but in the cool and wet season, perhaps that was diminished, but it didn't see quite the magnitude of effect that we're hoping to see in that wine analysis. So this is taking a look at the UV-vis SPF of the phenolic fingerprint of the aged sparkling wines. So again, we can see that the separation there is primarily according to vintage along that PC1, and that's driven again by very similar compounds to the base wines. So in these wines, however, we did measure the coumaric and caphteric acids, and high levels of coumaric acids were observed in the 2010s to the 2011s, and it'll be interesting to delve deeper into this and to see whether that relates to this fingerprint as well, because there was a vintage difference in the coumaric, but there wasn't a treatment effect. So the crop load treatments didn't actually have an effect. The second PC was driven more by treatment separation in 2010 along PC2. And so there are other hydroxycinnamates other than caphteric and coumaric that could potentially be contributing to this as well. And so that is something that we're going to have a look at in more detail in the future as well. Oh, sorry, and there's I forgot to put the little ovals around to show you the difference between the treatments there in 2010. So we could still see quite significant good treatment clustering there of the high treatments compared to the low ones, whereas in 2011, where they were side by side, they actually are a bit more spread out now. So we have the high is kind of a bit more distributed, whereas the low sort of sits in the middle of those high ones. So this slide takes a look at a lot of the compounds that were analysed by the AWRI, but not all of them. So we have a lot of compounds here which are contributing to flavour and aroma. And it may look like the wines that we made all had rather unpleasant flavour and aroma by the descriptors that I've put in there, but there were just more of those types of compounds that we were analysing than necessarily the pleasant ones that we were after in our sparkling wines. So we can see in this plot here that there was more treatment effect between the 2010s, in 2010 again. So because these are further apart and there are more compounds which are contributing towards driving that separation on vertically, so we have a bit more of a treatment effect. But over here in 2011, our treatments are more tightly clustered together, and they're actually represented by being closer together on this plot. Obviously, we have the big difference between the two seasons here, and it's a very big difference. And it's also, as we go through the other trials, we'll start to see some differences which are similar between the trials, but are as a result of the season. So we actually did an informal of these wines in 2013, informal tasting of these wines at a Wine Tasmania workshop that we had, which has also contributed to why there aren't as many bottles of wine to analyse in the last couple of years. But we took them and we just basically asked for preferences for what people, which wines that they preferred. And it was a resounding high crop load preference in both seasons. So in the 2010, from the 2010 season, which was our warm and dry one, there was a clear preference for the 13.3 tonne per hectare wines over the 5.5. And this is after they'd had about 30 months entourage. And in 2011, which is our cool and wet year, we also had a clear preference for the 18.4 tonnes per hectare over the 8.2 tonnes per hectare. And that was after they'd had 18 months entourage. So we'd hand disgorged them before the workshop and took them down and it was basically a show of hands for that one to see which preference there was. But then it was interesting when we had a look at these wines after they'd both had 5.5 years entourage. So they, in the previous workshop, they were all looked at on the same day, but these ones, they were looked at a year apart so that we could get the same time on lease. So we see that the 2010s, there was actually a preference for the low crop load for the 2010 wines. And then there was a very slight preference for the high crop load in the 2011s, but it wasn't as much of a difference between the treatments as there was for the 2010s when we tasted them. So if we take a look at the volatiles again and have a look at which were the preferred treatments, we can see that both of the preferred treatments sit up in the top part of this plot. So perhaps that means that the styles of wine that people are making are more driven by some of these compounds which are sitting up in the top quadrant here when it comes to driving preference for wines. So, and it's interesting that the stronger preference was for these two, which are also separated more on this plot, whereas the preferencing between these ones was actually much closer together, and they actually sit closer together on the plot. So there's a lot more work that needs to be done with these, particularly with me working with the AWRI, to better understand how our yield differences as a result of pruning have been driving some of these compound differences. And then I thought I'll also just put on there, which I found was quite interesting, that the yield of 5.5 tonnes per hectare in 2010 was preferred, but the yield in the cool and wet year of 2011, it was 18.4 tonnes per hectare, which was preferred. So that's a bit of an interesting yield difference there. So we'll take a look now at a leaf removal trial in Chardonnay, which we did in northern Tasmania. So these are some of the parameters that we looked at. So we've got little yield difference between the trials. I think a lot of this was to do with vine-to-vine variation as well. So we can obviously see that 12.4 is tonnes per hectare is quite a lot higher than 8.2. However, they didn't come out as statistically significant, but we can see that there are some trends there. And also with this trial, we had a rain event coming in 2010. So we actually picked it earlier because of the quantity of fruit that we had to process. So we then tried to pick the 2011s earlier as well. And then we saw some pH differences in the cool and wet year of 2011, but we didn't see any TA differences in that one. And again, just sort of, there's, 200 growing degree days difference between these seasons when I talk about cool and warm and dry and cool and wet. So taking a look at the base wines, we could see again that really strong seasonal variation. The treatment clustering isn't as distinct as it was for the crop load, but we can see that the pre-flowering treatment does separate out in the 2011 season. And being a cool and wet season, perhaps this makes sense that we've opened up our fruit to that increased light interception earlier in the season, and that would drive some differences that we would expect to see in phenolics. And then we can also see that the next leaf removal treatment time, which was when berries were pea-sized, that does separate out from the pre-flowering one, but then we don't have great separation there from the veraison timing of leaf removal or the control. And then we can see some treatment clustering as well with the pea-sized berries in the 2010 season as compared to the control. So those two treatments appear to be different to each other, but then they don't appear to be different to the veraison. It's a bit confusing. We don't have pre-flowering leaf removal treatment in this year. We only decided to add it too late. We missed our time point. So when we had a look at the aged sparkling wine analysis, they looked really different between the seasons, but there were very little, there was no treatment effect on the parameters that we had a look at. When we take a look at the aged sparkling wines, we can see again that there's a bit of a change there from the way that the base wines, where they sat on the plots, and the phenolics that were driving the differences between those. But when we take a look at the volatiles, we can see again clear vintage separation. But what I started to notice was that in 2011, we're seeing some of these similar compounds still displaying as higher in the 2011 season than with the majority of the others sitting over here in the 2010s. So we can see some treatment separation of the leaf removal treatments here, with the control being driven by, we've got compounds up here like methanol, which is like cabbage, phenylacetaldehyde like honey, or the rosy, the 2-phenylethyl ethanol, sorry. And then we can, so that's in our, and then, oh, sorry, I got confused. Sorry, that's the veraison treatment. And then down here, this is the control treatment. And we can see that the control treatment displays some characteristics like the fruity ethyl acetate and ethyl butanoate, and also some banana characteristics like the 3-methylbutyl acetate. So again, we've got better treatment separation in our warm and dry 2010 than we did in our cool and wet 2011. So when we had a look at the tasting panel preferences, we weren't able to have our 2010 wines tasted by the expert winemaker panel. But when we had a look at the 2011s, there was a preference for the pea-sized timing of leaf removal ahead of the veraison leaf removal to pre-flowering, and the control was the least preferred there in the 2011s. So again, if we take a look at our volatiles, and we can see that our most preferred was our pea-sized leaf removal. But again, it wasn't a huge preference difference. It was just the one that came out on top. I think what would have been really interesting would have been, had we been able to taste these 2010 wines that had that seemingly larger difference in terms of the volatile composition, what the preferences would have been for that. So we'll take a look at the same trial, but applied in southern Tasmania. So this is an inherently lower vigour, lower capacity site than the northern site. And also, it's a region which has less rainfall than the north usually does. The temperatures are slightly different, what have you. So if we take a look at the basic parameters, we can initially see that the yields are also much lower at this site when we're looking at similar bud numbers. And also we had an impact on the sugars as a result of leaf removal with a delay in the control, particularly when you compare it to the two treatments which were applied later in the season. And then we can also see that, that we had some TA effects as a result of those leaf removal treatments. So that is looking at our fruit composition. So if we take a look at our base wines and the potential effect that we've had on the phenolics, again, we get that large seasonal variation as well. So, likely driven by those low molecular weight phenolics. But then we can see that the cool and wet 2011 also showed separation between the control, which is that nice skinny little lips there, and also the pre-flowering treatments. So, which was similar to the leaf removal timings that we saw at the Northern Tasmania site. When we take a look at the analysis of the aged sparkling wines, there were very large differences between the vintages in the wines, but those four parameters there, glucose, fructose, pH, malic acid and VA, didn't show any treatment effects that came through there. But we did see that TA was lowest in our pea-sized leaf removal treatment in TA, and also the alcohol was lower. And so that's an average across the two seasons. So again, we get, so the features that were sort of driving the separation of these aged sparkling wines were between 260 to 280, with 330 playing a little bit less of a role. And we can see that the 2010 pre-flowering treatment here separates out nicely from the control. And it also separates out from the Veraison treatment here. But here in the 2011s, we don't see that kind of, treatment clustering that we were looking for. When we had a look at the volatile analysis, we have the Veraison again separating out here in the 2010s, and that's attributed to compounds like 2-phenyl ethyl ethanol, which is, the rosy and floral compounds, or the sour acetic acid. And again, we still see those similar compounds being attributed to these 2010 wines. So it's a different variety, different location, and different treatments, but still seeing the same compounds driving those differences. So the winemaker preferences that we had for these were for the Veraison leaf removal treatments in this Chardonnay in both 2010 and 2011. So we can see that that's the winemaker preference there, sitting there in the 2010s, and in the 2011s, sitting there. So they're relatively neutral. They're not too out there when it comes to how they separate out from their treatments. So interpreting some, and then also we've got there the, that's around the pea-sized berries, and that was the next most preferred for that one. So it does make it quite hard when we're interpreting these, because everybody's looking for different things according to the style that they are producing. So some people are looking for more floral and fruity notes, whereas other people I have found would prefer something a bit more neutral, that then they can just apply their own sort of more complexity through their winemaking techniques. So the next steps in this project are, we are definitely still pulling together and interpreting all this data. That information that we're gathering around the wine styles is very important, and also keen to sort of gather more information about the preferences of what people are actually looking for in their base wines and in their sparkling wines, and pull that apart as opposed to looking just at the viticultural practices. And then we've also got other tasting data of specific attributes within the wines that we're attributing to the different compounds which have been identified. So at the AWRI Sparkling Symposium next month in June, we're also going to be tasting some of these wines along with looking at the data at the same time so that we can try and get a better understanding of that. So this has been, as I said, a really big project with a lot of people involved, and none of it couldn't have happened without all of these people involved. And that's it from me. Thanks, Michael.
Okay, great. Thanks very much for your fantastic presentation there, Fiona. We're going to move now directly into a Q&A. So if you have any questions for Fiona, please stick around. Just a reminder that if you do want to ask a question, just open the Q&A part of the webinar and type in your questions and click to send them through. While we're waiting to receive any questions, just a quick reminder about the next AWRI webinar. That's going to be held on the 31st of May, so in a fortnight's time. The topic is the formation and remediation of stinky sulphur aromas in wines, and it will be presented by the AWRI's Dr. Marlies Becker. There's a registration link on the AWRI website, so if you'd like to take part in that session, please go onto our website and register. Okay, Fiona, we've got a question here. So Paul's asked, in summary, vintage has a greater effect on wines than crop load. And that's a question. So crop load doesn't matter for sparkling.
Crop load does matter for, yeah, so vintage does have the greater effect than the treatments, but then we could see that there was an effect of crop load within each season. So it does matter because you get different compounds that are in your final product as a result of the high or low crop loads. We need to do more work at investigating that, Paul, and working out, because they were two pretty big differences, two pretty big yield differences that we were looking at there. I think it was, you know, a comparison of 5.5 to 18.4. And also I'd like to look in more detail at what happened between 2013 and a few years later where the preferences actually changed from high crop load to low crop load. So crop load does matter for sparkling. It's also just around understanding that style and what people are after and how they want to get there.
Okay, thanks Fiona, and thank you Paul for your question. If you've got any follow-ups, send them through. Another question here. I noticed lower crop load in 2010. Had what appeared to be much higher malic acid levels. Any thoughts on that, Fiona?
So Beck, I noticed that as well when I was pulling this together, and I haven't had a chance to look into that in more detail because I've been focusing on the volatiles so much because that's a newer area for me. So I can definitely take that on notice and grab your email address or something and get back to you on that if that's all right.
No problem. I'll send you Ben's contact details. And
oh, Ben, sorry.
That's all right, and follow up later. No more questions as now from our audience. Quick one from me though, Fiona. I know that you mentioned you'll be discussing this research at next month's Sparkling Symposium in Melbourne. Beyond that, do you have any information on how or when these results will be released?
Definitely trying to get these out by the end of the year. So it was really good having this and the next time point. So we got a lot of this data last month, and having this month, and then the symposium next month. It means that we can sort of get those out in a more timely fashion. And so yeah, definitely hoping to get the majority of this out by the end of the year.
Great. Okay. A couple more questions have come through in the meantime. Is the malic due to temp and wet differences between seasons?
I think it might be, but I just haven't had a chance to actually take a look at it. So I'm not confident in answering that, but I think it might be, yes.
Yep, cool. And another one here from Matthias. Did you assess the influence of crop load and leaf removal on the content of N compounds. Is there an influence on yeast nutrition?
No, we didn't actually look at that, but that is a very good point that obviously the fruit composition is going to affect, because we use the same yeast year in and year out at the same rates. So it obviously, when we have a look at the differences that we get from the fermentation derived volatiles and we see differences there has to be a reason, but we didn't actually measure it.
Yep, okay. So that looks like it's it with regard to the Q&A for today. Fiona, did you have any final comments before we sort of start to wrap up?
No, just thanks to so many people for listening.
Yeah, it's been a great session. Thank you. Yeah, certainly want to thank Fiona for providing the content for this information and sharing results from these trials. Also like to thank you, the audience, for participating in today's session. All attendees will receive a follow-up email with a link to this recording. As I mentioned, our next webinar is on the 31st of May. Details should be there on your screen now. And that's all we have for today. So thank you again for joining, and I look forward to seeing you at the next AWRI webinar.